It is day 25 in Algebra 2, and it is Monday, November 17th. And today we're going to review a little bit of Unit 4, our exponential equations. So let me actually title this Exponential Equations. So exponent, exponential, IAL at the end. Exponential equations. Okay. And last week we solved exponential equations where we did something with bases. So I'm going to give an example here. I have 3 to the x power equals 3 to the 12th power. To solve this, what are we looking at and what do we do?
The bases match,
Uh-huh.
so you'll cancel them out.
Uh-huh.
X equals 12.
Good. So this is the simplest version. We are looking to see if we have bases that match. And in this case, we do. Our bases, the big numbers, are both 3. When the bases are the same, we cancel them out. So cancel, same, bases. So this is just a review to start. And then, of course, we just bring everything down. Whatever's left is x equals 12. And that was a nice one. It's already solved. X equals 12. So these are nice. When the bases match, all you do is cross them out. But now we need to think about what happens when the bases don't match. For example, 3 to the x power equals, let's say, 27 to the 5th power. Now what do we do when the bases are not the same?
Get them to match.
We want to get them to match. When bases are not the same, let's make them the same. And how would I do that? Which number or which base am I going to try to match? The 3 or the 27?
Match the 27 to the. Or no.
Yes, you're right. You're right. We want to match the 27 to the 3. So basically, we want to match the 3. We want both bases to be 3. We want to pick the smaller number. So I'm going to make a little note beside when bases don't match. What we're doing is we're trying to rewrite 27 with the base number as 3. So we're trying to say 3 to the what power is 27. So when bases don't match, how should we write that? When bases don't match, what would we write there? I'm feeling unsure how to word that right now. When bases don't match.
You gotta take the base number and try different exponents to make them match.
Yeah, okay. So yeah, we'll use the smaller number or the smaller base and try different exponents to get it to match. Okay, so when bases don't match, use the smaller base. Try different exponents. To match the bigger base. That's a little wordy, but that's what we're doing. kind of wordy, but it's what we're doing. So my bases don't match. I want to make both of my bases the smaller number. So we're going to use that smaller number 3, and let's try some exponents. So what are some ideas?
Three times two, keep going up till
Now we want to be careful whenever we say that. We're saying 3 to the second power.
3 times 3. No,
Yeah, or 3 times 3. Yes. So we'll try 3 to the second power. 3 up 2. Remember, it's that up arrow under or right above the division symbol.
The 0. Can I see the top?
Yes.
3.
So 3 up 2 gives me 9. 3 up 3 gives me 27. So basically we're rewriting 27 with a base of 3. And what we would do to have a base of 3 is 3 to the third power, right? And you can double check that when you type that in. 3 to the third power, I get 27. So what will I do here?
Replace the 27 to the 5th power with 3 to the 3rd.
Yes, so we're going to replace my 27, just 27 though.
You're gonna rewrite those.
I'm going to replace 27 with 3 to the third power because that's the same as 27. And then what?
Bring down your 3x and equal sign.
Bring down everything else. We have 3 to the x power to bring down. We have an equal sign to bring down. We have one more little thing to bring down. The 5. The 5. Because 3 to the third power is 27. It's not 27 to the 5th power. That's a bigger number. So we still have to bring this 5 down. So I'm going to highlight that by using kind of a different color here. I'm going to say, don't forget to bring down your other exponents. And where would that 5 go?
Next to the. Would you add it to the 3rd power?
You wouldn't add it.
Multiply?
Multiply. Yes, you would bring down that 5, and it gets multiplied with the exponent, the 3. So I'm going to say, don't forget.
So it'd be 3x to 15?
Yes, yes. So don't forget to bring down exponents. So we brought down the 5. And then, exactly right what you said. Now we can do the 3 times 5, and that gives us 15. But what's something else we could do here? What's the same now?
Cancel out your bases.
Cancel out my bases. When we have the same bases, which now we do, we have 3s, I can cancel them. And then what comes down?
X equals 15.
X equals 15, or X is 3 times 5. Good. Uh-oh, somebody's calling someone. And that would be your answer. That would be your answer. Okay, so we give one more example like this, where it's more than just one little exponent there. Now let's say I have 5 to the x power equals 625 to the, let's see, 2x minus 1. I don't know if this is going to give me a decimal. We'll see. So what would I do here?
So use the
Yeah.
smaller base and try different exponents.
Yes. Yes. So first thing we notice the bases don't match. So let's try to make them match. We're gonna make them match the small one. We have 5 as our base. So how can I rewrite 625 with the base of 5?
You could do 625 divided by 5 and then put whatever 625 divided by 5 as the numbers.
Can I do that? Let's see. 625 divided by 5 gives me 125.
So you could do 5 to 125.
So let's double check that. 5 to the 125. That's not going to work. So if it was, powers are different because whenever I am doing 5 to the something power, it doesn't mean 5 times that number. It means 5 times 5 times 5 times 5 times 5 times 5 as many times as that power says. So I can't just divide by 5 here. I need to try numbers like 5 to the, I'll try 2, then 3, then 4, and keep trying until you get 625. 5 to the 4th. Is that what you're going to say, Charles?
Yeah.
Good. So remember, if you don't know, this is what we'll do. We'll type in 5, my up arrow, and then I'll say like, oh, let's try 2. Oh, no, 25. 5 up 3. 125, we're getting closer. 5 up 4. There it is. 625. So now I know 625 is the same thing as 5 to the 4th power. So what do I do now?
Replace your 625 with 5 to the 4th power.
Yep.
Then you'll bring down 5x equals and 2x minus 1.
Good. So I replace 625 with 5 to the 4th power. I'm going to bring down 5 to the x power equals, and then we're also bringing down the 2x minus 1. Where do I bring that down though?
It's to your fourth power.
Yes, bless you. Next to the 4th power, and it's being multiplied. We're always going to bring it down in parentheses next to the exponent. So now what?
You multiply 4 by -1.
Yes, you're going to definitely end up distributing and multiplying those things.
Cancel out your bases.
Yes, I would cancel your bases before we start messing with exponents just so that we're not working with too many things at a time. You could do it all at once if you want, but I like to kind of, once my bases match, I like to get rid of them because it cleans my problem up a little bit.
Bring down your x equals.
Yeah, so bring down x equals, and then I have 4 times 2x minus 1. Okay, and now I'll distribute. So we'll do 4. What are we multiplying by
4
first?
times 2.
Yes.
6, 8.
4
Or
times
8.
2x. Yes, I'm fine. You're okay. You're okay. 4 times 2x is 8x. And
-4.
yes, the 4 times the -1 gives
So
8.
x equals -2.
-4. You might be right. I haven't solved it yet. Let's see. I'll bring down my equals. I'll bring down my x. And now I'm going to draw a line.
Distribute 8 on both sides.
Distribute 8. So what am I going to do with 8? Add, subtract, multiply, divide. Divide?
You can divide, subtract.
If I want to get, okay, if 8x was totally by itself and there was no -4, there was no x on the other side.
Oh, subtract 8
Yes.
on both
Yes,
sides.
yes. Let's get our x's together. We can subtract 8x from both sides. Because I need to combine my like terms. -8x. Good job. Okay. That gets rid of my 8x.
Only 7x.
Yes. But not just 7x. What?
-7.
Yes. Okay, so x, or basically 1x, minus 8x is negative 7x equals, what comes down?
Negative.
-4.
Good, negative 4.
Right.
Good, good, good. And last step, we will get a decimal, but that's fine.
Divide.
Good. 5, negative 7 from both sides. And what does that give us?
0.57.
Yes, 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 yes. And it is positive. Those negatives cancel, so we get x equals
Positive 0.574.
0.571. Thank you. Perfect. Perfect. Good job, guys. Okay,
One
so
trick question there. Yeah.
okay, let me give you one similar to this. I want you to try it on your own. Make sure that we got this from last week before we move on to what we're going to be learning today, which is very similar to this, but actually, believe it or not, it's weird, but it's a little bit easier, I think. So let's do 4 to the 2x power equals, say, 96. I gave to the, let's go with x plus 2. Okay. So, try this one. Try this one. Pause this, and I'll give you guys a few minutes to try that on your own. All right, y'all have had some time. Try this. Does anybody feel confident to tell me what to do? How do I do this?
First, you're gonna make like terms.
Make like terms. What you mean?
Turn the 4096 into that square root.
Square root, kind of. Are you talking
Make
about
like-
getting the bases to match?
Yeah.
Yes. Okay, so we see that our bases don't match. Let's make them match. We're going to rewrite that 4096. And what can we use instead? 6th power. Okay, so 4 to the 6th power. We can double check it. Yep. It's a little blurry, but it does say 4 to the 6th power is 4096. Let's see. Yeah, there you go. Now you can see it. 4 to the 6th power. So I'm replacing 4096 with that. And then what do I do?
Yeah. Bring down the rest of it.
Yes, bring down the rest of it, everything else. So I have 4 to the 2x power. I have an equal sign. And then my x plus
That's in
2.
parentheses.
Yes, bring it down in parentheses on the exponent. Okay. Now what?
Cancel your bases.
Cancel out your-
Yes, cancel your bases now that they match. Now what?
Bring everything else down.
Bring everything else down.
So 2x equals 6 times 2 plus x plus 2.
You did x plus 2. Okay.
Draw a line in the middle.
Yep, draw a line through the middle.
Distribute.
Distribute.
So 6x plus 12.
Good. So 6 times x is 6x. Plus 6 times 2 is 12.
And then bring down your 2x.
And then bring down your 2x in equal sign.
Subtract 6x on both sides.
Yeah, now let's get our like terms together. Now, before we start finishing this, I heard a few people, or somebody, I don't know, I thought I heard somebody get confused or something when we got to this next step. Did somebody make a mistake or something that they noticed?
Oh, I did.
You did? What mistake did you make?
I did it both ways. I did the 6x and then I got the numbers and then I went and rewrote it again and did the 2x. But whenever I did it the 2x way, I accidentally put negative 4x plus 12.
And I was looking at it.
Because it gave me a decimal. It gave me
Oh.
2.4.
That's funny. Okay, so just to kind of reiterate what's happening here, all we did is we rewrote 4096. We replaced it with 4 to the 6th power because that's the same. 4 to the 6th power is 4096, so we replaced it. Then I just took my 2x, my 2x here, brought it down there, and then whatever was left over here was the 6, and then the parentheses, the x plus 2, the other parentheses. So I brought that here. Then I see 2x equals 6 outside of parentheses x plus 2. We distribute, so we multiply to both terms. And now we're here. We brought everything down. And we have 6x plus 6 times 2 gave us 12. Does everybody understand how we got to here? Okay. So now, Jocelyn or Amber, I can't remember which one of you said it, we'll subtract that 6x. We want to combine our x's. And what happens?
Your 6's on that side are going to cancel out.
Good. My 6 is canceled.
Do 2 minus 6 would be negative 4x.
Negative 4x
Equals positive 12.
equals positive 12.
And then you're going to draw the line
Mm-hmm.
to divide.
Good. Divide. To get x by itself, we'll divide by negative 4. And then what?
X
Mm-hmm.
equals negative 3.
Yes, 12 divided by negative 4, x equals negative 3. That's our answer. Nice. Did anybody get that right? Good, yeah.
I don't even know how I don't even know what's going on.
It's good. We're getting the hang of it. This is hard. This is very hard stuff. You guys are really doing good.
That's
Awesome.
what got me when I even tried it, cause like I was doing the exponents and I figured out the 4 to the 6th power was the 4096 part, then I had that brain for it. I'm like,
Right. It's like, okay, I got that number, but what am I doing with that?
right.
We'll do some more practice to make sure that it'll become second nature. It will. We'll get it to stick. This is new stuff still, so sometimes it just takes a minute. So you guys, that is wonderful. It is 10:15. I'm gonna give y'all a break. So I will pause our recording. We did a really good review on our first half. I would like to start back up at 10:30-ish. Give you guys about 15 minutes here. So I will pause, take a break. I'll see y'all in a little bit. Maybe closer to 10:31. Okay, we are back from our break. This is where we left off, and what I was just about to mention to you is, in every example of an exponential equation so far, we have always been able to make the bases match so we could cancel them. But that doesn't always happen. Sometimes we cannot get the bases to match. And so we have a magic trick. It really is like a magic trick because I truly don't understand how it works, but it works. I'm going to show you what we do when the bases can't match. So I'm going to flip my page, and first I'll write that this was page 1 of my notes. And we will start page 2 here. Continuing, this is day 25, notes continued. Page 2. And go up here. And so we're going to write, or I'm going to write up here, what do we do when the bases can't match? So, what do we do when bases don't match? What do we do? To explain this, I'm going to show you an example that goes along with it. Bless you. And we're going to learn about a new thing and another new button on our calculators. Okay. We're going to use something called a logarithm. Logarithm. So what do we do when bases don't match and we can't make them match? We use logarithms. 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 Logarithms.
Is it?
And we call these logs. We can just call them logs. Yeah, that's how it's normally said. Because logarithm's a long, long word. We're just going to call them logs. And what on earth is a log in math?
I don't know.
But we're going to use them. They work. So on your calculator, you will notice right under x squared, there's a button that says log, L-O-G. That's your log button. We're going to use that today. When you click that button, let's see what comes up on your screen. You get this where it says log parentheses.
Yeah.
Okay. Okay, perfect. So this is going to be kind of like whenever we have to type a square root, you got to push that button first and then you type the number. So we push log and then we'll type a number in. So I'm going to clear my whole calculator. And let's look at an example where we would have to use logarithms. So the example I'm going to give you is 6 to the x power equals 8. Without knowing what a logarithm is, thinking back to what we did earlier today and last week, my first thing to look out would be, do my bases match? No, they don't match. Okay, so if they don't match, what we normally do is we try to get them to match using the smaller base. So maybe I would look at my 6 and say, can I do 6 to any power and get 8? So let's try 6 to the first power. No, that's 6. 6 to the second power. 36. We've already passed 8. So it's impossible. I'm not going to get the right number unless I go through and try every decimal known to man.
You do 6 plus 2.
6 plus 2?
Yeah, like 6 squared equals 6 plus 2.
6 plus 2. I know 6 plus 2 is 8. But
you have your 6.
And you would have your 6. So I'm going to tell you why we can't do that. That's a really good idea, though, because that would be the same thing as 8, 6 plus 2. The reason I couldn't change that to 6 plus 2 is because it's 6 to the x power. So if I change this to like 6 plus 2 to the x power, this is not
what I meant. I meant
like, what'd you mean?
6 squared equals 6 plus 2. So then your 6 will be there. Yeah.
Oh, okay. Well, like 6 to the x, since I don't know what x is yet, right?
Yeah.
Okay, so 6 to the x power equals 6 plus 2. Okay, I see what you're trying to do here.
Would it work?
I'm right off the top of my head, I want to say I don't think that will work. But let's hold on to that and solve it one way first. And then I'm going to come back and see if it works. don't think it does. Let's hold that. We'll hold that thought. Put it to the side. Because right now we're going to use logarithms. I'm pretty sure that's not going to work though, but there's a good idea. Good idea. Okay, so whenever our bases don't match and when we cannot make them match, what we need to do is use what's called a logarithm. So here's what happens. Let me put this fully to the side. So I'm going to make a note that says, when we can't get bases to match, what we do is it sounds odd, but this is how we say it. We're going to take the log of both sides. So I'm going to show you how that looks. Take the log of both sides. Meaning the 6 to the x power and the 8. Whenever I take the log of a number that has an exponent, here's what happens. My exponent goes out of the exponent spot. It's going to come down to the front. X. Right here. So here's my x. Then log. And then, so I'm going to put x here in black. And then we have 6. So what happens? My base goes after the log. My exponent goes in front of the log. So basically this is x times the log of 6. That means we've gotten the exponent out of the exponent spot. Equals, now we're going to take the log of the other side, 8. So I'm going to kind of color code this a little better. Putting my bases in blue, my exponent in pink. So multiple more examples so that it makes sense with what we're doing. So my bases couldn't match, so I'm going to take the log of both sides. Move the exponent to the front. Log of 6 equals log of 8. And I want to solve for x. So here's what we can do. I want to get x by itself. Log of 6 is like one value. This is a number, believe it or not. Log of 8 is a number. This is my equal sign. Draw a line. This means x times whatever the log of 6 is equals whatever the log of 8 is. If I want to get x by itself, remember this is x times the log of 6. I want to get rid of the log of 6. That would give me x by itself. So here's what we'll do. I'm going to divide both sides by the log of 6. Hear me out. Let's divide by log of 6. I'm going to show you how to type this in. And then what would happen over here, you think?
The 6s will cancel.
Yeah, my log of 6s would cancel. And then what would come down? My x equals, and here's how we get our answer. So once you're to this point, let's get our calculators out, and I want us to pay really close attention to how we type this. So I'm gonna wait till everybody's ready. Here's what we do. Make sure you're looking to see. I am now just looking over here. What this says is the log of 8 divided by the log of 6. So we will type log 8. Now, notice there is a parenthesis in front of your 8. You have to close that parenthesis because this is log of 8. Close the parenthesis. Divided by. So you push your division button.
Hold on.
Okay, so I'll wait till we're here. Log of 8 divided by.
Log of 8.
Close your parenthesis after the 8.
Wait.
If you don't close your parenthesis, you will not get the right answer.
Divided by.
Divided by, now we'll type log again. 6, close parenthesis. Hit enter. You're going to get a weird number, 1.16055, and so on. Is anyone getting something different than this? Give me thumbs up when your calculator says this number. Yes. Okay. Believe it or not, that's your answer. So 6 to this power equals 8. 6 to whatever this 1.160558422 should equal 8. If I want to check that, look what I could do. 6, up arrow. Let's put it in the X spot. 1.160558422. Enter.
Up arrow.
Ah, look at that. It's pretty darn close to 8.
Okay, what did you put in?
That's
So what I
number?
did is I just typed in 6, and then I used the up arrow to get to the exponent position,
Mm-hmm.
and then I typed in the number that we just got for x. That 1.160558422. When I hit enter, I see that it's very, very close to 8. And it won't be exactly 8 because this number goes on further than my calculator will show me. So it's approximate, it's not exact. Okay, so our answer for x is that number that we got. We can round it if we want. We could say 1.16. That would be just fine. And that is our answer. So that's a little uncomfortable because it's something we may have never done before. Let's run through a few more of these and just get used to the process. And before that, going back to the 6 plus 2 suggestion, I'm going to say no, that won't work. I don't think that's going to work. I can play around with this later and see if there's any case where we could do something like this, but I think it's not gonna work. It's okay though. Okay, so we take the log of both sides, divide by that to get the x by itself. Let's do another. So I'm gonna do it right over here beside another example. How about 4 to the x power equals 5. 4 to the x power equals 5. Look at the problem we just did. What should we do here?
Take-
Yes. We're going to take the log of this 4 to the x power, which brings my x to the front. X. And that's going to be times log of 4. So x times log of 4 equals, and then what should I do?
Log of 5.
Yes, log of 5. When you get to this point in algebra 2, I remember doing this in high school and thinking like, we're just playing around. Like, what is this? But once you know the process, it's actually pretty simple. Pretty simple once you know what you're doing. So what do I do now? I want x by itself.
Yeah, divide both your sides by the log of 4.
Yes, and that's it. Let's divide both sides by the log of 4 to get x by itself.
The same answer.
Is it really the same answer?
Close.
What?
1.160.
That's crazy. Okay, well maybe I should pick numbers that are further apart. Okay, so I'm going to type in again log of 5, close your parentheses. If you don't, your answer will not be correct. Divided by log of 4, close parentheses. I'll hit enter. Yeah, it's super, super close to that last answer. 1.160964047, which I suppose we could just round again to 1.16. So yeah, it's about the same answer. So that log of 4 canceled on my left side. We did log of 5 divided by log of 4, and we got x equals about 1.16. Crazy. Crazy. Hey, let's do another one of those, and then I want you guys to try one on your own. Let's use bigger numbers this time, just so I don't know, mix things up. Example, let's try 12 to the x power equals 50. Well, to the x power equals 50. What would I do?
Start off by rewriting it and bringing your x in the front.
Yep. Okay, so we're gonna bring our x to the front, and what are you doing to rewrite it? What are you adding in?
X multiplied by the log of 12
Yes, x times the log of 12.
equals 50 times the log of 50. My bad.
Good, equals log of 50. So we're taking the log of both sides, moving the x to the front. And then good, Diane, divide what? What are you dividing?
Divided by 12.
Log of 12, good. Divide by log of 12. Hopefully we get a different number than 1.16. Let's see.
Close.
Let's see. It's close? Oh man.
It's 1.something.
Okay, so log of 50. Close my parentheses. Divided by log of 12. Close my parentheses.
See.
Enter.
57.
1.57. It's different. So our log of 12 is canceled. We get x equals 1.57 approximately. Not an exact answer. These are all approximate since the decimals are so precise. Guys, let me give you one to try on your own. I think y'all got it. Let's do, try this one now. How about 16 to the x power equals 453. Bump it up a little. Okay, try that one on your own. I'm going to give you guys a couple minutes here.
Do have one to
Yeah, what's up?
when we doing this version, is it always going to be solid numbers or would there ever be decimals?
It could be decimals. If it was decimals, you would still do the same thing. You would just put a decimal in there. We can try one with a decimal next. Okay, so what do we do here?
You rewrite it
Okay.
at the parentheses log of 16
bring down my x, and then we'll do log of both sides. Log 16 equals, then what?
Log of 453.
Yes, log 453.
Then I'll divide it by the log of 16.
Yes, divide by log of 16. 5 by log of 16 on both sides.
So 2 log of 16s will cancel out.
Good.
X equals 2.20.
Okay, bring down my x equals, you said 2.20. Let me type it in. Log of 453, close parenthesis, divided by log 16, enter. Yep, 2.20584181. Yes. Yeah.
Put it in.
Okay.
I think we did it right.
2.2.
If you were rounding 2.21, yes. If you put 2.20, I won't count it wrong. But 2.21 is a good answer for rounding. So I'm going to put 2.21 just for the sake of rounding. And that is our answer. Good. Okie dokie, guys. That is wonderful. So, this is what I want us to do.
Why would we write this? Why would we write this side twice? Because that could be kind of confusing.
What side twice?
This side, you say log 16,
Mhm.
then you put the divisions, the line under it, which is the division side.
Uh-huh.
Then you put log 16 again. Instead of just writing out log 453 with parentheses, and then putting the line, the division sign under the bottom with log 16, just write it just like that, so we'll know just to work it like that.
Because you're dividing both sides of the equal sign by
Yeah.
16.
Yeah.
So we want to write both of them because if I don't, we're basically just writing out what's happening kind of in our head.
Yeah.
Log of 16 divided by log of 16 is 1, which is why I have 1x by itself left. So we have to cancel that. And we have to do it to both sides. What you're saying would be a lot like this. I know log 16 is a lot more to write than something that we're used to, but let's say, for example, I had 5x equals 25. It makes sense why I have to write the 5 again. I divide by 5 on both sides. We're doing that here. We're dividing by log of 16 on both sides. I need to write the 5 here so that I know to cross it out. If I don't write log of 16 underneath, I might forget to cross it out and think that it's still there. So we need to cross it out so that I can get x by itself. And then I do that.
That's why Rhino writing it double.
Yes, that's why
I
we're
wrote
writing it
6
double.
I wrote 16 twice.
Yeah, we're doing it double here so that we know it cancels. Just like with this, we're writing 5 twice so we know it cancels. Yeah, that's a good question though. Good question. Okay. Let me see. Let's check to see if logs work for some of the ones that we did like earlier. How about somebody give me a problem we did earlier. What was one where the bases matched?
Three x equals 3 to 12th power.
Okay, 3x equals 3 to the 12th power. So let's see if this works to give us x equals 12. Here's how we would do it. So let's take the log of both sides and see what happens. So when we take logs of sides of our bases and things, remember the exponent comes out to the front. So x comes to the front, and then we're doing log of 3, right? Equals Now, over on the other side, I have an exponent again. What would I do with that exponent?
Right in front. And then
Yes.
three.
Same thing I did with the x. Because it's an exponent, bring it out to the front. So I'm going to put 12 first. And then log of the base again, log of 3. Okay. So I took the log of both sides. I brought my x down. I brought my 12 down. What would I do now?
Divide, both sides by the log of 3.
Yeah, let's divide both sides by log of 3. That will give me my x by itself. So if I divide by log of 3 on both sides, log of 3, what happens?
Your threes cancel out.
On this side with my x, my logs of 3 cancel. What about the other side?
You get 12 of them.
My log of 3 divided by log of 3 also cancels. If you want, you can type that in. You've got log of 3 divided by log of 3, 1. So basically you have 12 times 1, which is still 12. We canceled that log of 3.
So x will equal 12.
X equals 12. Yep, which is the same thing as canceling the base. We just made it harder. We did more steps.
Right.
So when the bases are the same, it's going to be easier to cancel them. Doing the logs is helpful whenever the bases are not the same.
So it's the
So-
same. Go ahead. I'm sorry.
No, you're good.
It's the same
the
thing.
same
It's
thing.
just an extra step.
Yeah.
When you get the answer when
Yeah.
the bases aren't the same.
So this is kind of more the long explanation of why we cancel the bases when they're the same.
Surprise.
Yeah. There we go.
Did you round up for the one that got x equals 2.21?
Yes, it was 2.205.
Okay, perfect.
Yeah. Okay, good.
Perfect.
Okay, and then we just did another example, but this time where the bases were the same to show that we can still do it this way,
Use the log button.
but we'll get the same answer. Yeah. Okay, guys. So I'm gonna give you an exit ticket. You've done awesome today.
You've done awesome today.
Oh my goodness, that's so kind. Okay. Does anybody still need this before I move it? Okay. So I'm going to write this exit ticket. You are welcome to write it yourself. But if you do, please, please, please write the title on it. If you are wanting to wait a minute or maybe take a little bathroom break while I'm making this, I am going to run copies of it. Or if you're looking ahead to the final exam and you think you're going to do a portfolio, maybe you want to wait for the copy, up to you. But this is due Friday, November 21st. And this is the day 25 exit ticket. Tomorrow, for day 26, that's your last exit ticket in here ever. Woo! No. Yes. So this is the day
Working on those.
25 exit ticket. For your exit ticket, I want you to solve the equation X using logarithms. Which is exactly what we just did. We're going to do just one. Here, 2 to the x power equals, make sure I don't pick a number that 2 works with. 648. Okay, that's your exit ticket. I will run copies of this. So, or actually, I won't pause. I'm gonna end it. That is our lesson today. This is your exit ticket. If you finish, you are free to go. Yeah, I'm gonna run copies and I'll be right back.